Hey guys, welcome back to the channel. Sorry, it's been like 2 weeks. I finally got a camera holder for my phone camera. So the first two videos were like such poor quality because I was trying to use my laptop camera, and that thing was this Peter was bought back in like 2019, so the cameras were not as great back then. And now they make phone cameras almost as great as like high-end cameras. So hopefully the quality is so much better. But my name's Tim Hobbs. You guys know your favorite DCIM, which DCIM engineer, which stands for Data Center Infrastructure Management. For those that do not know, your job is to maintain the infrastructure of the building, which means you're managing the BMS, EPMS systems via SCADA platforms. So, the purpose of my channel, yet again, is to, number one, tell people that we exist. This is a job role that does exist. Everyone knows about data centers, but you have to have decent engineers that help keep them afloat. And I want to encourage people, so of course, let people know DCIMs exist. Two, what it is, because yet again, you guys heard my first two videos. When I was DCIM engineer, when I was, being headhunted to be a DCIM engineer, I could find no information, only QTS called DCIM engineer. I didn't know who these people were, could find no information on YouTube. Like, they give me real life examples of what I was walking into. So this is me just paying it forward to anyone else that hopefully if they get headhunted by my company, they just type in DCIM into YouTube and hoping my stuff pops up, and then at least do a couple videos, a couple shorts, and figure out, okay, what is this, So no one likes walking into a situation blind, and so this is me paying it forward. But so this first couple videos, I'm going to go through different just walk through the the job posting, and walk through the decent responsibilities and talk to you guys realistically, like what these are day to day. Because I think you can have a job posting that says one thing and may sound like super technical or super intense, and realistically, I can tell you it's actually just this. So hopefully it's less daunting for you. So we're gonna get started with that. Alright guys, so let's talk about the first responsibility. I'm going to read it verbatim and then break it down. So the first one is ensure DCIM, Data Center Infrastructure Management systems, are operating as designed to protect the data center, capture power usage, calculate available capacity, and provide meaningful, timely alarms, notifications, and reports to end users. So what does this mean? Let's start with ensure DCIM systems are operating as designed to protect the data center. So, right, in a data center for your BMS, which stands for Building Management System, so this is going to be your HVAC, heating, ventilation, AC. So you have an HVAC system. So your SCADA platform should be controlling the HVAC parts of the building. So how you're cooling the data center, your different data halls, your different spaces, right? You're keeping them warm in the cold months, keeping them cold in the hot months, right? Your humidity levels, right? You're gonna have equipment. So your BMS system should be managing that. So if let's say you have a data hall that is way too humid or something, or not humid enough, or it's not cooling the way it should, your job as DCIM engineer is to figure out why. Is it the SCADA platform? Is it the code? Are you using a PLC to control that space? Is the PLC code not optimized? Or is it the equipment in the space that's, maybe your code is perfect. It's telling, the system to run at this certain supply temperature set point or something, and it's not doing it. So is it the equipment in the room? So it's kind of like, you need to figure that out. You're in charge of that for BMS, for example. So when you talk about making sure that stuff works, it's ensuring that your BMS equipment and the code and SCADA platform that's running them is actually working correctly. Or is there an issue somewhere? Is there a network issue? Are you not communicating to like 10 of the devices in the room, so it's not being controlled properly? Stuff like that. That's what they mean by that. Because the data center, right? If a room gets too hot, you're going to damage customer servers, right? And that's a no-no. If it gets too humid, right, they're going to get wet and then start shorting out. If the room gets too dry, right, you can have static discharge problems. So it's like, when they mean protect the data center, we're talking about like literally protecting data center from that standpoint. Or if you lose main power, make sure your gens work correctly, like that they're programmed correctly. that the programming works for those. Even though vendors write that kind of stuff, but like it's like you need to make sure all these things work, because like if you lose main power, you need to have backup power kick on, for example. So that's what you mean by making sure both of your systems work to, protect data center. Let's talk about calculate power usage. So power is a huge thing in data centers. Like obviously the power coming in to the building to supply everything is important, but also monitoring that power and then calculating its usage. So you probably heard a term, you type in Google, called PUE, which I believe stands for power utilization efficiency. So it's measuring the power that you're given, how well you're actually using it, or using it efficiently. So that's something that you have to be able to calculate. So how this usually works is you have to be able to calculate the power coming into the building and then the amount of load being used. So usually it's called IT load, for example. That's like the load of the IT equipment, right? And then obviously you have the utility power coming in, and then you divide these two numbers and you get a very small number. A perfect PUE is like 1, right? That means for every single watt you're using efficiently, right? But realistically, that's not possible. But it is possible, but it's like hard to find. So calculating power usage, you got to be able to look at doing simple math. You have different devices, EPMS, that monitor power usage, where you have a bunch of meters that measure different things. You have like power meters, for example. You need to be able to look at those, be able to know like the points they're getting. Kind of the difference between like real power, apparent power, and reactive power. You mostly deal with real power, kW. You do need to know apparent power, especially when you're doing power factor, especially like power factor. So things like that. So when it says calculating power usage, it's like, okay, knowing how to like do math and know like what devices are monitoring my power and be able to use those to do the math necessary to calculate how much is being used, because the way data centers make money in general is not my company specific. Is you have a tenant move into a space, right, and then they use power and they get charged based on that power usage. So it is a very important skill to be able to do this math correctly and make sure you can calculate how much power a tenant's using to make sure they're getting billed correctly, which makes your company more money. So very important skill. I'm not sure that mean by calculate available capacity. I would just say like that's be able to calculate your utility load, like how much power is actually coming in the building, like how much power is allotted. So if you have a 200 megawatt building, you can't support 205 type thing. So knowing the capacity your building can handle, yes. And then provide meaningful, timely alarms, notification, reports, and users. So a wonderful thing about SCADA platforms in a data center, we love alarms, reports, notifications, email notifications, different things like that. So when you have an alarm on a device, especially a critical device, you want to be able to have an alarm in the SCADA platform for the operator to respond to. You want to store that alarm somewhere in a database so you can always look back and reference, for example. And then you got to think about, okay, do we just want the operator to have that alert? No. Maybe you want me, the decommissioner, to have that alert. Maybe you want the maintenance team, supervisors, managers to have those alerts. So you got to be able to think about, okay, be able to manage, am I sending out notifications to the right people? Have it configured correctly? How am I going to configure that, for example? So is it phone calls? Is it emails? That's important to know in the sense of like timely, and then of course like, is it fast enough, right? If I get an alarm at 10 o'clock, am I getting an email at 10:10, 10:05, 10:30, right on the dot? And depending on your company, there's different ways how this is actually set up, but that's important to know. And then reports, going back to like power usage, sometimes you have tenants that want, they may ask you, hey, I need to know how much this particular circuit's using, and then you can calculate that by using different data points that are available. So yeah, sometimes you have customer specific reports. you have reports that your company provides, and this is like the biggest part of a DCIM. Like, you're the master of the database. So this really applies, it's both for BMS and EPMS. So they're going to store data in a database somewhere, and you have to be able to manage that database. And what I mean by manage is like being able to extract data from it, making sure it's storing data for a certain period of time, right? Like if your company says we need to store data for a year, you need to make sure you have it set up to store data for a year, right? But most systems in your company are going to, if it has to do with like EPMS, BMS, power usage, or efficiency of cooling in the space, that data is going to come from your actual field devices in the field, right? Like, and then those field devices store data in a database. So you, as a DCIM engineer, a lot of people are going to want to be able to extract that data from your database, and you have to know how to extract the data from the database, right, to get that data to them. Or if they're using an application that is pulling from your database and data is missing or something, you have to be able to like prove, for example, like, no, my data is in the database, I can query it here and show you like from these dates I have the data on these points, you know, like it's something on your end or something. Or maybe the data is missing, right? Maybe you're missing a power meter KW value and you're like, I had it for like 3 months and it stopped. Then you need to troubleshoot why that point stopped coming in from the field device. So a lot of database management. So all that kind of goes into like reporting as well, is you have to master this database and know how to work with it. So that's kind of that first responsibility. Second one, configuration of DCIM system applications in support of new data center deployments, new data requirements, and data center retrofits. So DCIM system applications. So depending how your company rolls out their SCADA platform, you may have to deal with virtual machines and VMs. So on these VMs, you have to install the softwares you need for your SCADA platform. So if you're using Ignition, or if you're using, I think, Viva Wonderware's out there, if you're using Dematic Visualization, there's so many different SCADA platforms you could use out there. I think there's another one too. He said Amazon. I can't remember what it's called. Start with a T. But or IntelliGrade. Like there's so many different SCADA platforms out there. You have to be able to install that software on those VMs, for example. Or if you're using PLCs, you got to be able to install that vendor specifics equipment. So like if it's Allen Bradley, be able to install RS Studio, RS Links, Factory Talk. If you're using a different brand of PLC, you can be able to install the software, right? So, and then some vendors, they have their own software and things like that. So you got to be able to install those on your system and know how to configure them and set them up to work on your VMs, right? Because you may have to deal with Windows or deal with Linux. Yeah, that's just kind of like a good way to know about supporting your data centers. So like when you have a new building come up, you got to be able to install these softwares, right? So that's important to know, and that's a pretty daunting thing, let me tell you. Hopefully there's documentation out there for the one you're using. New data requirements. So maybe back the last 5 years, you're only monitoring certain points, and now more points are available. So you gotta be able to adjust in that sense, or maybe speeds are getting faster, or maybe some customers want faster speed. You gotta be able to figure out how to adjust. And then the last part of that is data center retrofits. Man, these are rough. There's one data center in Manchester that's a retrofit. So this is what happens when, let's say you have an existing building that's already, let's say it's a printer factory or something, and let's say they want to convert that building into a data center. So that's a retrofit. Those are huge projects. I've never got to be a part of one, like from the start to finish. I've only been given the final product, which all I can say is retrofits are rough. So, you know, that I've never been part of that, but I'm imagining you're going to have to go through like all the design in the sense of like making sure you have electrical prints, make sure the SCADA platform works, the controls work. That's heavily involved. And DCIM engineer, you're going to be like the technical expert when it comes to controls, working with integrators. So I was talking about those two videos already, like 15 minutes long. So thank you guys for watching the video, and I hope this gives you a little more insight of like what those two specific responsibilities mean, DCIM engineer. And I hope it doesn't scare you away. Hopefully it excites you and opens you up for a new adventure. See you guys.